Hello everybody. So today I want to talk about calculus. The topic today is about differential equation. So now I want to show you how to answer. A mass 2 kilograms attached to a spring extends the spring 10 meters to equilibrium position. Let the damping constant be 3 and there is not any external force. So now I want to show you how to answer. We need to use about Hooke's law in here. So we have m, that is about the mass, multiplied by 3, that is about gravity, equal to k, and s that is about extend the spring 10 meters in here, and k that is about the spring constant. Now we need to find about k. So we have 3, that's about 10 meters per square seconds. So in this situation, we put number 2 cone here, number 10 cone here. S, we have number 10. And we know that k equals to number 2. So after we have this one, we can apply the formula to write about differential equation in here. So m, that is about number 2. So we put number 2 cone here. Alpha, that is about the damping constant, be number 3. So we put number 3 cone here. And k, that is about number 2. And this is the answer for question number 1. Question number 2. If the mass is released below the equilibrium 2 meters with velocity in downward direction 2 meters per second, then find the position of the mass after 20 seconds. So now I want to show you how to answer. So we know that's S0 in here. That's it for the position. And we know that this is below the equilibrium 2 meters. So we put positive number 2. If we do first the derivative of S, that is about velocity. And we have positive number 2. So we put number 2 in here. Now we have this equation in here. We can find the equation. So this one we can use about complementary solution. So I will put about y sc equals to e to the power of lambda t. So if we do first the derivative of sc, we have lambda e to the power of lambda t, because if we do first the derivative of e to the power of lambda t, we keep the same e to the power of lambda t. Later that we do first the derivative of lambda t, we have lambda, and later that we do second the derivative of sc. So we have lambda square e to the power of lambda t. And now we put this one cone here. this one go in here, and this one go in here. Now we can do about factorization by e to the power of lambda t. So we need to find the solutions of this one. So this one, we have lambda equals to negative number 3 over 4. And we have the square root of number 7 over 4i. That is about the complex number in here. And the second one, we have about lambda equals to negative number 3 over 4 minus the square root of number 7 over 4i. So this one we can put st. That is about e to the power of negative number 3 over 4t. And I will put about 8 cosine with the square root of number 7 over 4 t. And we have b. That is about sine with the square root of number 7 over 4 t. Now, after we have everything in here, we have the conditions. So we put t equal to number 0, and we have number 0 going here, here, and here. So we have a equals to number 2. Now, if we do first the derivative of st in here, so we do first the derivative of this one multiplied by this one. Later that we do first the derivative of this one multiplied by this one. That is about the product rule of the derivative. So that should be like this. Now we put number 0 cone here. So we put number 0 cone here, 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 and here. So this one we have negative number 3 over 4 with a in here. And the second one, that is about the square root of number 7 over 4 b equals to number 2. A, we have number 2. So we put number 2 going here. to find the value of b. So b equals to number 2 with the square root of number 7. After we have a and b in here, we have the final equation of st. So we put s 22nd. That is from the question in here. So we calculate this one and we have 1.478 multiplied by number 10 to the power of negative number 6 meters. So we see that this one that is about positive, so that should be about below equilibrium. Why? So we know that if we draw the diagram in here, this is about equilibrium. Now I will put this one like this. So if we extend in here, we have s is greater than number 0. If this one we go back like this, this one s is smaller than number 0 because s is about positive in here. That means below equilibrium in here, and that's why we can answer like this. Now let's go to the last one. Assume there is no damping force and external force give one way so that the frequency of the motion increase. So we have this one. Now we don't have this one anymore. That means we just have like this. So we divide both sides by number 2. So this one we apply same formula technique in here. So I will write the answer. So we know that the formula of the motion they always like this. So if we look carefully about this one, the number next to t, that's about number 1. Number 1 that should be in here. So omega equals to number 1. And that is the final answer. This is the end. Thank you for watching.